So of the tidal volume, you've got less anatomic dead space in the patient with the trach tube. So of the tidal volume they get, more of it's going to make it to the alveoli. The more anatomic dead space you have, the more the tidal volume will just stay in the conducting airways in the anatomic dead space. Okay, minute volume. This is the total volume of air entering and leaving the lungs over 1 minute. It is the product of the tidal volume and the respiratory rate. So you take the tidal volume going into and out of the lungs, multiply it by how many times per minute the person's breathing, and you come up with minute volume. So if the normal tidal volume is 500 cc's and the normal respiratory rate is 12 breaths per minute, what is the normal minute volume? So 500 times 12, what does that give you?
6,000 cc's.
6,000 cc's.
6,000 milliliters.
6,000 milliliters, so cc's, milliliters, same thing. And then how do you convert it?
Divided by 1,000.
Divide by 1,000, or just move your decimal point to the left? To the left for liters. And it says that you have calculation practice in D2L. Oh, and there's practice here too. If the respiratory rate is 24 per minute and the tidal volume is 400 mLs each breath, what is the minute volume? 9.6 liters. And did you do it in mLs first?
Yes.
And what was that?
9,600.
Yeah, so 9,600 mLs, and then you convert that to liters. So if the minute volume is measured on the ventilator and the respiratory rate is known, how is the tidal volume calculated?
Divide.
What would you divide? Minute volume divided by? Yes, very good. So you would just manipulate, do your simple algebra and manipulate the equation to find the unknown. Do you need to see that on the board? Are you okay with it?
Yes.
So this you were okay with. You multiplied respiratory rate times tidal volume. We gave you the minute ventilation. The answer comes out in milliliters. And then you just move your decimal point or divide by 1,000 and you get 5 liters. Okay. Now what if you're given information about the minute volume is 10 liters. The respiratory rate is 20 per minute. What is the tidal volume? So you would take the same formula and rearrange it just by doing your general algebra, where if you want to get something by itself, you divide both sides by the other value.
Divide by the respiratory rate.
And respiratory rate over respiratory rate is 1. And then you end up with the tidal volume by itself, which would be minute volume divided by respiratory rate.
You would convert it back to milliliters.
Yes. Yeah, your tidal volume you want in milliliters and your minute volume in liters. how we would do this. You start off with your formula. Then you have to rearrange it somehow. Did I do the same one twice?
Divided by your resistance, so you divide 15.
It's 15.
A 100 over 15.
100 over 15.
No, it's 10 liters.
It's 10.
That comes out to 0.66.
0.66 ml? No,
Well, no, 0.66
liters.
liters and you convert
Because you know I'm not going to ask it directly on the text. Got to rearrange it for you. All right, what else have we got? Oh, the question at the bottom, that's like a critical thinking question on your exam. If the tidal volume is smaller than normal, so a person's breathing shallow, how does the body maintain the same minute ventilation?
Increase the respiratory rate.
Very good. I hear some people saying the answer. So with a small tidal volume, if you want to maintain the same minute volume, you just have to breathe faster. So if you have 100 ml tidal volume and you breathe 30 times a minute, you're going to hit your, what, 30 liter minute volume. So yeah, if your tidal volumes are small, you'll notice that patients will be tachypneic and they'll breathe faster to maintain that minute ventilation. Oh, and this slide is just telling you that when a ventilator gives you the digital readout for minute ventilation, it doesn't wait a whole minute and say, oh, this is what the minute ventilation was. It updates itself every few seconds. So it's just looking at like the past 60 seconds, this is what it is. So every few seconds you're getting an update on what the minute volume would be over a minute. But it's really looking at a few seconds of data. All right, and then I want to just spend a couple minutes and tell you about airway graphics. When any ventilator that you turn on, the first thing that you see are airway graphics. And I want you to be really comfortable with them, know exactly what you're looking at when you're looking at airway graphics. So this is just your introduction. It says, well, pressure, volume, and flow will be measured. What is pressure? It's measured in centimeters of water. Positive pressure is created by the ventilator during inspiration and at the end of exhalation. What is volume? It's measured in mLs or liters. Volume is the amount of air that enters the patient's lungs during inspiration. Minute volume is the accumulated volume over 1 minute. And what is flow rate? It's how fast the gas flows into the patient's lungs during inspiration. If 1 liter of air enters the lungs in 1 second, we say the flow rate is 1 liter per second. And then we can multiply by 60 to change to liters per minute. And then it would be a flow rate of 60 liters per minute. So those are the definitions. And what does it look like on a graph? All right, it helps when it tells you what the graph is. So if we're looking at flow rate, the 0 is the baseline. Everything above it is when the air is flowing into the lungs. And everything below baseline is the air coming back out. So here the patient's exhaling, all the air is coming out, and when it hits 0 or baseline, all the air has exited the lungs. All right, with pressure, this is showing you a spontaneous breath. It's a little negative on inspiration, a little positive on exhalation. All right, that's not that fair. And then volume. So the patient breathes in, the line goes up as the air goes into the lungs, and then it comes back down as the air comes out of the lungs. All right, so the ventilator gives a breath to the patient. We see pressure building. And then when the pressure comes back down, that's exhalation. Can you kind of line it up with the flow? So air is flowing into the lungs. It flows and flows and flows. Now the exhalation valve opens, and this becomes exhalation. So at this one point in time, inspiration ends, the exhalation valve opens, and now the air comes back out. And then the volume goes in, the volume comes back out. Why is it that instead of the pressure going down to 0 at the end of a breath, it stays at like 4 or 5 centimeters of water? Is it a plateau?
Not all the air.
And not all air comes out?
Not all the air comes out, so we're deliberately keeping the air in, or PEEP? Okay. So that's PEEP. PEEP, P-E-E-P. All right, identify the 3 graphics. What do you think the top graphic is? The units are centimeters of water, if that gives you a clue.
Oh, pressure.
That's pressure. Is there any PEEP set? And don't look at the number. Just look at the graphic. Can you tell if there's PEEP? Yeah, because this isn't down here at baseline. So you know that there's PEEP. What do you think the second one is?
Flow.
Very good. It's flow. You see liters per minute. That's kind of the giveaway. At the top of the line, is that exhalation or is that inspiration?
That's inspiration, and
And then here is the exhalation valve opening, and this is the air coming back out of the lungs. What's down here?
volume.
Okay, so volume goes in the lung, volume comes back out of the lung. There's a leak somewhere, because when you see this look, it looks like the letter V, but it's because not all of the air that went in came back out, and some is missing. And then the ventilator will reset the graphic down to baseline for the next breath to begin. So there's a leak each time. See how it's resetting itself, and then the breath starts. And even when you see VTI and VTE, so the ventilator put in 275 mLs, and only 215 mLs came back out. So as a therapist, you check your circuit. Well, we go through all of that later on, but that's what you do, is you look to find out where it's leaking and you fix it. Okay, let me tell you about a hysteresis curve. So this is one breath that goes into the patient and then comes back out. You would think that when you push air in, when it comes out, it would have the same pressure going in and going out. So you'd expect one line, but it's different. So for this, I call this like the belly, and this looks like the turtle shell. So the belly is the air going into the lungs, but then when the lungs empty, pressures are different, and that gives it a different look. So inspiration is different than exhalation. Pardon me. All right, so looking at this, can you tell what the peak pressure is? So you look at the point, the furthest point over, and then you look down. And that tells you what the pressure is? It's over 20, right? Maybe like 22 or something?
23. What's the axis?
Did you peek? All right. And what was the maximum volume that went into the lungs? So you go to the top, and then you come across, and you look to see what the volume is. Yes, about 500 mLs went in.
So the x-axis is peak?
The x-axis is the peak inspiratory pressure? Yes.
And then the y-axis is volume?
Yes. And then you can look at a breath when you compare the air flowing in to the volume. So for now, all I need you to tell me is what is measured on the x-axis? Very good, volume. And what's measured on the y-axis? Flow, liters per second. That's it. And inspiration is on the top. Exhalation is on the bottom. So go ahead, write that part in. Inspiration is on the top. Exhalation is on the bottom. All right, identify the two graphics. We'll start with the one on the left. What are we looking at? You can look in your notes.
Flow versus volume?
Yes, that's the flow volume loop. Very good. And how much volume was delivered? It's kind of hard to see that number, isn't it? I think 500 ml. And then what was the fastest flow rate when the breath was going in?
40.
Yeah, 40 liters a minute. Was the red the inspiration or was the red the exhalation?
Inspiration.
Inspiration. Good. All right, what is this called? The hysteresis curve? And what is the maximum pressure that built up in the lung when the volume was delivered? Pressure?
Between 10 and 20.
Okay. So about 20 centimeters of water?
Yeah.
Okay. And what was the volume that went in?
500.
Yeah, then you look on the y-axis, about 500 ml.
Is the red inspiration and the blue expiration?
Yes. Very good. And that ends this presentation.